Good morning, students. Now we'll see the topic of numerical methods 1, that is module 1 in applied mathematics 3. We'll see the overall topics now. Excuse me. In this, we have these topics. Mainly, you can divide into three main topics, and in each main topic, you have two subtopics again. First one is numerical solution of algebraic and transcendental equations. In this, we are going to study about two methods. One is regular Falsi method or method of false position. Second one is Newton-Raphson method. The second main topic is interpolation with equal intervals. In this interpolation with equal intervals, we are going to study two methods again here. Newton's forward interpolation formula. Second one is Newton's backward interpolation formula. Next, third subtopic is interpolation with unequal intervals. In this, again, we are going to study with the two formulae. Newton's divided difference interpolation formula. Second one is Lagrange's interpolation formula. These are the overall syllabus in this module 1. Then we'll go to first topic. Introduction about this one. We can go through the introduction about this one. I'm not to explain here. Next, first topic, numerical solution of algebraic and transcendental equations. Under the first method is regular Falsi method or method of false position. How we can solve in this one, we'll see. Let f of x equal to 0 with a given equation. By trial and error method, identify 2 points A and B such that f of A less than 0 and f of B greater than 0. We have to identify two values by trial and error method such a way that at one value, the function value should, at one point, the function value should be negative, and at another point, the function value should be positive, which means that the root of the given equation lies in between the A and B values. If you identify these two values in such a way that then the root of the given equation lies in between A and B. Now, by regular Falsi method, an approximate root of the given equation is given by the formula x is equal to a into f of b minus b into f of a divided by f of b minus f of a. This formula you are going to use. Now, we will see the problems. First one, find a real root of the equation x cubed minus 2x minus 5 equal to 0. Correct to 3 decimal places by using the regular Falsi method. Actually, this is algebraic equation only. You can solve normally also, just from known to unknown. I'm trying to correlate the method. We have to find out the root of this equation. Given equation is x cubed minus 2x minus 5 equal to 0. Complete, take the left hand side function as f of x. F of x is equal to x cubed minus 2x minus 5. After listing that function, you have to find out the 2 points by trial and error method. Generally, we'll solve from 0 or 1. We'll start from 0 or 1. F of 0 is equal to, if you substitute x value 0 here, you will get minus 5. Then f of 1 is equal to, similarly, we will get minus 6. F of 2 equal to minus 1, still it is negative only. F of 3 is equal to 60. Excuse me. Now see, at 2 the function value is negative, at 3 the function value is positive. And you know that the polynomial is a continuous function. When you draw the graph from 2 to 3, it will touch the x-axis in between 2 and 3. Means the f of x equal to 0 lies in between 2 and 3 only. Means f of 2 less than 0 and f of 3 greater than 0. So a root of f of x lies between 2 and 3. So we'll take a is equal to 2 and b is equal to 3. Why? Because means where it is negative, always take it as a. Where it is positive, always take it as b. Then by regular Falsi method, an approximate root of the given equation formula will write down x equal to a into f of b minus b into f of a divided by f of b minus f of a. Now we have to substitute a, b and f of b values on this, and we have to find out x value. After finding x value, check the sign of the f of x value. Check the nature of the f of x value. If it is positive, take this x value as b and repeat the procedure again by taking a as same value. Suppose at this x value, the function value is giving negative. Take this x as a and b will be same as it is and repeat the procedure until and unless you will get an appropriate required appropriate value. That I am going to show in a tabular form. The process of finding the root is shown in the following table. Now we'll see in the following table. F of x is equal to x cube minus 2x minus 5. And formula x is equal to a into f of b minus b into f of a divided by f of b minus f of a. Now I took the table a column, f of a column, b column, f of b column, and then x, and then f of x. First, a equal to 2, f of a value already calculated, b is equal to 3, f of b already calculated, 16. Now use these four values in this above formula and calculate x. We will note down it as x1. First approximate value, 2.0588. Substitute this value in the function and calculate f of x and decide the sign also. F of x1 is giving it as less than 0. So it is less than 0 means take it as a. If it is greater than 0 means take this value as b. And the remaining will be carry forward as it is. Here a is changed, f of a, b will be as it is. So f of b will be as it is. Now substitute these second stage values in the formula and calculate x and this x2. Find out f of x2 less than 0. So if you proceed the same procedure in a similar manner, you will get x3 and f of x3 is still negative. Take this as a again, f of a, b same, f of b same, calculate x4 and f of x4. Still it is negative. It will goes to a only. And f of a, b, f of b, x5 and f of x5. Still it is negative only. Now, see, still if you proceed in the similar manner, up to where you have to do means where the x value will repeats up to the required number of decimals. It is asked in the question, it has corrected to 4 decimal places. That's why up to 4 decimal places, it should become it as same. If it is asked in the up to 3 decimal places in the question means you can do up to 3 decimal places only. Up to 3 decimal places only means see, here only you got it. Up to x7. Hence, an approximate root of the given equation is x is equal to 2.0945. Okay, next problem. Estimate an approximate root of the equation x e power x is equal to cos x corrected to 4 decimal places by the method of false position. Okay, now we'll see the second problem. Estimate an approximate root of the equation x e power x is equal to cos x corrected to 4 decimal places by the method of false position. In this, you have to remember one important point. Whenever the trigonometric functions are there in the given function, then while calculating the values f of 0 or f of 1 or f of 2, we are substituting the radians. So don't forget to put your calculators in radian mode when we are doing this type of problems. Means a function has trigonometric function and you are using calculator, make sure that what type of values you are going to enter, either radian values or this degree values. According to that one, change the mode of your calculator. Given function is x e power x is equal to cos x, transfer to one side, x e power x minus cos x equal to 0. So f of x equal to 0 means f of x equal to 0, f of x is x e power x minus cos x. Now, by trial and error method, guess the values where function is negative and positive. F of 0 minus 1, f of 1 2.1780 means the root lies in between 0 and 1. But if you observe the previous problem, it went up to 8 approximations, 8 iterations. So to decrease the number of iterations, what we will do is select the middle point where the root lies in between and decide the function value at that point and then take the appropriate value. Now, f of 0.5, why? Because means midpoint of 0 and 1 is f of 0.5 is also giving negative, means you can omit f of 0. So the recent negative and recent positive values are at 0.5 and 1. So we'll take 0.5 as A and 1 as B. And by regular Falsi method, formula will note down and then proceed the remaining procedure in the tabular form. Same. Write the function and the formula table A column, f of A column, B column, f of B column, x and f of x. If you want, you can decrease the number of columns also. A and f of A in one column only, B and f of B in one column, x and f of x in one column. One by one you can write. A is 0.5, f of A value, B value, f of B value. By using these 4 values in the above formula, you will get x as x1 and f of x1 is negative. So it will come into A position. And same, repeat the procedure. You will get approximate at the 6th stage. See, even if you take the midpoint also, you got the root at the 6th stage. If you proceed up from 0 and 1 only, with 0 and 1 only, it may lead up to 10th stage. Or more than 10th stage. Hence, an approximate root of the given equation is x is equal to 0.5177. We will see the one more problem. Excuse me. Predict a real root of the equation x log x base 10 is equal to 1.2, correct to 4 decimal places by regular Falsi method. Given function, if you transfer to one side, x into log x base 10 minus 1.2 equal to 0. Sometimes if base 10 is not mentioned, nothing is mentioned, is simply log x is there, you have to assume it as log x base e. If base 10 is mentioned, so that is corresponding base 10. Then what is the difference between log base 10 and log base e or normal LOG? Means in your calculator, base 10 means it will be represented by LOG button. Without base or base e means in your calculator you have to take LN. Please remember this one also. And the remaining procedure is normal. F of x equal to 0 means f of x equal to x into log x base 10 minus 1.2. Now by trial and error method, you have to guess 2 points in such a way that the function is negative and positive at those 2 points. Here the function log is there, so you can't take 0. Why? Because means log 0 is not defined. That's why you have to start from 1. F of 1 is equal to minus 1.2 and f of 2 equal to minus 0.5979. So still negative only, f of 3, 0.2314. So root lies in between 2 and 3. Now take the midpoint of 2 and 3, 2.5. At 2.5 also negative only. So required values of A and B as A is 2.5 and B is 3. Once you list A and B, then you can proceed by regular Falsi method formula and table. The table procedure is normal, same. A, B, f of A, f of B, x, f of x, A 2.5, B 3, and substitute these 4 values, you will get x1. Repeat like this. You will get required approximate root at a 4th stage, x equal to 2.7406. Okay. So like this, you can do more number of problems. Okay. You can practice the remaining problems. We will go to the next method in the next video.